M1 Dynamics example 20. In this example, we're going to use the principle of conservation of momentum. We've got two particles, one of mass 2, which is particle P, and it's moving along with a speed of 3 meters per second. So as you read the question, label your diagram. It's on a smooth horizontal plane, and particle Q of mass 3 is at rest on the plane. So the initial speed there is 0. Particle P then collides with particle Q, and after the collision, Q moves off with a speed of 2/3. Now, if you think about it, the particle P is coming from the left, Q is going to move off towards the right. So afterwards, its speed V is going to be 2⅓. We've got to find, first of all, the speed and direction of motion of P after the collision. So it's possible that P would come along and bump into Q and just be slowed down, but carry on going in the same direction. Or if you imagine playing snooker, it's possible that this could come along, hit Q, and bounce off in the opposite direction. So we're not sure which way it's going to go. So for now, I'll just take it in this positive direction to the right, and I'll call that capital V. So using the principle of conservation of momentum, we know that the momentum before the collision is equal to the momentum after the collision. And if you remember, at any given time, the momentum of an object is given by the mass multiplied by its velocity. So before the collision, we have a mass of 2 moving at 3 meters per second. And then we have a mass of 3 moving at 0. I'd still put that in to show that you've considered it. Then after the collision, well, we don't know what's happening here, but we do know that this mass of 2 is going at some velocity that we need to work out. And then the mass of 3 is moving off with a velocity of 2⅓. So they're all in the positive direction, so I've taken them all as positive. So we've got 6 on this side, and then we have 2v plus 3 times 2⅓, works out to be 7. So solving this linear equation, we get that V is actually equal to -1/2. What that tells us is that P moves off after the collision with velocity 1/2 meter per second. And then we need to say in the opposite direction or in the reverse direction. So it was coming along from left to right. And now because we've got a negative velocity, that means it's going the opposite way. So it's going from right to left. So that's part A. We've now got to work out the magnitude of the impulse received by P in the collision. Well, we know the impulse is given by mv minus mu. So let's see what's happening for P. Let's draw it again underneath. It's got a mass of 2. It was coming along initially with a speed of 3, and now we know it's moving the opposite way with speed of 1/2. And if you think about it, which way would the impulse act? Well, the impulse would act to the left. It's being knocked by particle Q back towards the left. So the impulse is actually moving off that way. It's over to the left. So if I was to call this I, the impulse, then I'm actually going to call it, when I do my calculation, minus I, because it's going to the left, and I'm taking to the right as positive. mv is going to be 2 times -1/2, because that's also to the left. And then we're going to subtract mu. So that's going to be 2 times 3. And that u is positive, but we are subtracting it, so that stays as a negative. Now, if you notice, everything here has got a negative. So if I multiply through by -1, we'll get that I is 2 times +1/2, which is 1. And then that negative will become a plus. 2 times 3 is 6. So in other words, the impulse is 7. And we know that that's measured in Newton seconds. So be really careful when you do these questions with the direction and make sure you're really clear about which way you're taking as positive.